Okay, Pierre, we're going to do statistics. Are you camera shy? All right, so good morning, 8th grade. We're going to be doing statistics today again. This is our last lesson in statistics, lesson 5. So good morning, Pierre. Okay, Pierre, you can go now. All right, so our learning target for today is we can compare statistics from data sets. Again, we can compare statistics from data sets. All right, so the main idea here is to see if we can compare across data sets to make decisions. All right, so in your warm-up, you'll have a chance to do such a comparison. All right, so we're gonna have this scenario, as you see in your warm-up sheet, is about two people's track record in bowling. So these people are bowling for 25 games. Each person A and person B, has bowled for 25 games. And we are trying to see if you had to choose one of these two people to be a part of your particular team when you're going to bowl, which one of these two people would you choose? All right, so we have some data here. Which of these people would you choose? All right, and so you have the graphs on your paper. All right, so study that and make a decision based on statistics. So this is what you're given to make your decisions. For person A, you have a mean of 118.96. For person A, you have a median of 111, standard deviation of 32.96, and an interquartile range of 44. So that's person A. For person B, you have a mean of 131.08, a median of 129, standard deviation of 8.64, an interquartile range of 8. And so you are asked to make that comparison. All right, so go ahead and do that. You will have, I think you could do that in 3 minutes, right? All right, so you should be finished with your analysis by now. Okay, so if you decided you want a person like person A to play on your team, you might have had an argument of talking about the high score. All right, so now that you're finished your warm-up, we can actually look at the some conclusions that you might have drawn. All right, so did anybody choose person A because they wanted a person who at least might have a chance of hitting 200 points in a game, even though they don't do it often? All right, so person A has a greater variation. Did anybody see that? And so if you want a person with the possibility of hitting those high scores, at least 5 of the times this person was hitting scores at 140 or higher, right? So you might choose that person, right? Some people might say it is not as stable a scoring mechanism going on here for person A because the values here are kind of like not very high at the end. All right, so what I mean, they're high at the end, but the frequency, is not very high. Okay, so 140, 150, 160, 170, 180, 190, 200, those scores happen only the frequency of 1. All right, okay, so the person who chose B might be looking at the mean and say, I just want a person who has a higher average. They might be looking at the low interquartile range and a low standard deviation, they might be saying there's less variability here. So I'll take my chance on a person who is stable, who is always going to be scoring around 130. They might not score high, but I need a person who is stable and who is going to hit a lot of scores in the 130s, all right? Whereas person A, most of their scores, their most frequent score was around 80, even though they had some high scores. All right, so that's some of the analysis that you may or may not have come up with, all right? Okay, so that's that. I am going to ask us to move on to, yeah, so before moving on, let us discuss measures of center and variability. So we're going to discuss measures of center and variability. Variability. All right, so we need to discuss measures of center and variability in order for us to basically finish this lesson. All right, so measures of center literally means the center. All right, so when we talk about measures of center, we are talking about measures of center. We are talking about median that you can definitely see when you work on a dot plot. So this is a dot plot. Or when you work on a box plot. All right, box plot because it has a box, like a rectangle. And these measures of center that we see in these diagrams, the measure of center that we see rather, is going to be the median. And we would have to calculate to find the mean. So the median and the mean are measures of center. Now, for variability, so we just talked about measures of center. For variability, we can calculate the mean absolute deviation, or we can use the standard deviation from the calculator. Standard deviation is very challenging to calculate, which you can do later on when you probably take AP Calculus or college, AP Statistics or college statistics. All right, but sometimes we don't have to go and calculate the MAD. We can just look on the box plot and calculate the IQR, and that really is a measure of give us information about variation. All right, so the IQR can give us a measure of variation. It's an interquartile range, or we can look at the entire range to see the variation. All right, so range is also about variation, but it's not as strong a measure as mean absolute deviation and standard deviation. Again, the range is a measure of variation. So the range would be, in this case, would just be 17 minus 13, which is 14. All right, the MAD, we would have to do some calculation to find that out. And here the interquartile range is easy. We can look at Q3 and Q1 and subtract them, all right? So that's what we need to think about while we move on to the next set of problems, which we will discuss. And also, you will have a chance to do some work from your workbook, all right? So I'm gonna put some problems before you, and I'm gonna ask the class to think about them. And we can kind of discuss that from where you are, and then we can go into group work, all right? Okay, so we are gonna look right now, I'm still here. We're gonna be looking at some distributions, and we're gonna be comparing 1A to 1B, 2A to 2B, etc., right? So, and we're gonna compare them with regards to the measures of center, and also with regards to the measures of variability, right? So for hope you can still see it. Okay, good. So for for number 1, if you look at 1a, you notice, let's look at a number line. You notice in 1a, all right, in number 1, you notice in 1a that the mean is going to be greater, simply because the values in 1a are greater, all right? So they're less negative than the values in 1b. That is, the values are further to the right on the number line in 1a. Therefore, the mean would be greater, right? Got it? And for 1b, it is the standard deviation for 1b is going to be greater, right? Because the data values rather are spread further out from the mean in 1b than they are in 1a. For number 2, the mean and the standard deviation would be appropriate measures for center and for distribution, all right? Because the data is symmetric, all right? All right, so the data is symmetric. But if you notice, the mean for the distribution in 2b is greater, since the center, again, is further to the right. And the standard deviation for 2a is going to be greater, since the data is spread out more, all right? All right, the median and the interquartile range would be appropriate measure for the distributions in number 3. And usually when you have any form of skewness, all right, any form of skewness, or when data are spread out a lot, or the data is spread out irregularly, that's when you're going to go to the median, all right? Because in that case, the center, geometrically, the center is not going to be shifted by some existing outlier. It's not going to be shifted too much away from a normal center when you have an outlier, if you're using the median, all right? A student from 801, Malik, answered that question beautifully yesterday when he talked about the median being resistant to outlier. Like if Jay-Z would come into the neighborhood, the median income would be about the same, but the mean would change, all right? All right, and we can look at number 4. The mean and the standard deviation would be the one that you want to use as measures of center. As measures of center, yes, for the mean, and standard deviation for the variation, all right? And so if you do that for number 4, you're going to find out that the mean distribution for 4a is going to be greater. The mean for the distribution in 4a is going to be greater, since the center is to the right, further to the right than in 4b. And the standard deviation in 4b is going to be greater, since the data is more spread out in that distribution. And for 5, the median and the interquartile range is going to be good. And you should kind of know that, right? The median and the interquartile range would be good because you're looking at box plots. Okay, so when you get box plot, you go straight to median and interquartile range. All right, and the median for the distribution in 5a is going to be greater, since the median is 700. But for the 5b, the median is only 500. And the IQR is going to be what we're using for the variability. And the IQR in 5a is greater. It's 300, but only 200 for 5b. All right, and so for number 6, the distribution is greater. Think about it like this, right? The values are concentrated on the ends for the political podcast, right? While the cooking podcast has values that are closer to the center, right? So 6A is going to have more variability, right? Okay, so things are spread out more in 6A. All right, and for 7, we have distributions that are symmetric, and so the mean and the standard deviation will be best. And I think that's all we can do. I don't think we're going to have much time for more else, right? Of course, I'm still going to be talking. The video is not going to be doing everything because we want to also have your teacher say something in class, right? All right, so we're going to be going on to the cool down, which is going to be shared with you. And after the cool down, we could summarize the lesson. We can take questions if you have questions. All right, so I hope this was something that was beneficial to you. And you will also, you can also go and check it out on Welly Math. All right, on the Welly Math, Bread Math rather. You can go check it out on Bread Math and Welly Homeschool. All right, so that's what when I was doing homeschool, that is my YouTube channel for education. All right. All right, cool. Oh, before we do the cool down, I almost forgot problem sets. So some of you might get to the problem sets. Hopefully, all of you. So here you have 2 dot plots that you're comparing, right? In problem set 1. And so you should be able to see that the distribution is symmetric, right? Which means we can use the mean for the measure of center. So whenever the distribution is symmetric, we can use the mean, right, as a measure of center, and the standard deviation as measure of variation. All right, so they're not asking you to do any calculation. Just look at it. Do you see symmetric? Yes, it's symmetric. Each of the distribution is symmetric. Therefore, we can use the mean. Each of the distribution is symmetric. Therefore, we can use the standard deviation as a measure of variability. So again, standard deviation is a measure of variability, and the mean as a measure of center. All right, so that's what we have there for problem 1. Okay, and let me look at it myself. Okay, you should be able to see that in situation B, you're going to definitely have more variability in situation B, because you see that value on the left that caused that means that there's a bigger spread. You can see that, right? There's a bigger spread in the second situation. So therefore it's going to be more variability, greater standard deviation in B, 1B than in 1A. All right. And the question is about the mean. Obviously, in 1A, you're going to have a greater mean, because in 1B, that score of 70 would pull the mean down. So it's almost like you have the mean that is given in A going well. Think about you having these test scores, and then you get a 70 after you already had a lower. After you had scores 75 and above, you get a 70. That 70% is going to pull your score down. So in case of A, we have a lower mean. In case of B, in the case of B, we have a lower mean. And in the case of A, we have a greater mean. In the case of B, we have a greater variation. All right? You can look at, I would skip over to problem 3. All right? So problem 2 was like you inventing some situation, but I prefer going to problem 3. All right? So in problem 3, you're given some information here, right? Given information here in problem 3, which you have in your workbook. All right? So let's look at it. In problem 3, you can see that we have a mean of 16.52, and we have a median of 16.95. That's given to you in your workbook. And we have a standard deviation of 3.11, and we have an IQR of 5.5. And so now, after you have this data set, we have a few questions that you had to answer. All right, so if you add 5 to every single value, you should be able to see that if a teacher decided to give you a bonus, on which we're not going to be doing, on every single test that you have, and add 5 points to every single test, then your test average should go up by 5, so the mean would increase. But the standard deviation does not change because the distance now of all the values from the mean, that distance will be the same. It just means that all the values, including the mean, got shifted over to the right by 5 points, but the shape of the data is the same, right? You should be able to see that. Now, okay, cool. So the shape is going to be the same and the standard deviation is going to be the same, but the measure of center is going to be different, right? So the mean is going to be different, obviously, and the median is going to be also different because 5 points were added to every single value in the data set. All right. So one last problem, number 4, with the box plot. Let me see what we have here. Number 4, the box plot, you can see that we have an IQR of less than 10, and we would basically be looking at the median for this. That is what we are looking at for both plots. So this is the first plot. Over here, we can see that the IQR for the second one is definitely greater than 10. So the first one, the IQR is less than 10. You can see it visually. For the second box plot, the IQR is greater than 10. All right, so you should be able to see that the second one has more variation because it has a greater IQR. All right. Okay, so B has greater variation because it has a greater IQR. Now let's go back and look at the median. So for A, you can see that the median is approximately 105 for A. And for B, the median is less than 105. Isn't that interesting? So for the first case, the median is greater for the first case, right? Which we just saw. The median is 105 for plot A. The median is 105. And for plot B, the median is less than 105. However, plot B has greater variability because it has a greater interquartile range. So you can have a situation in which Q3 is greater, Q1 is smaller, and yet, even though you have this widespread with the interquartile range, it doesn't mean the median has to be great. You can have a small median even with a large interquartile range, all right? I mean, small, obviously, in the box. The median cannot be outside the box, all right? All right, so that was it. Hopefully this is helpful and you can go and look at this video on Bread Math and Welly Homeschool, my YouTube channel, if you want to watch this again and see what we did in class. Sometimes it's good to look over something. All right, enjoy.